Hello, this is Team 76's Physics 3A project. Today we'll be talking about forces and torques, more specifically frictional force. Here's our question. Say you're trying to dump a wooden coffin with a mass of 54 kilograms into a hole. The coffin is loaded halfway on an 8-meter truck bed, and the truck bed can raise the front end to dump things out the back. At what angle does the box begin to slide? The coefficient of static friction between the box and the truck is 0.5. I just take this time to try to answer the question now. Why don't we start by taking inventory? We know that the mass is 54 kilograms. It is 4 meters from the end of the truck. And that the coefficient of static friction is 0.5. The principles we'll be using for this problem are Newton's second law and the definition of frictional force, because it's going to be static. There will be no acceleration, so we'll be using static friction. So for this problem, we'll be start out by drawing off a little simplified diagram. And we have the box here and the slope of the truck, as well as the angle. And for this problem, we'll designate the coordinate system to be the positive x direction is down the slope, and the positive y direction will be perpendicular to that, going against the slope, I suppose. So here we drew a force diagram of the box, and here we identified this upward force as the normal force, which is equal and opposite to the y component of the force of gravity here, and the force of static friction, which is equal and opposite to x direction. This portion should equal force in the x direction over force of gravity, so here over the hypotenuse. So you can simplify that to be force in the x direction to equal force of gravity times sine of theta. Okay, and this one you can define as force in the y direction over force of gravity is equal to cosine theta, which can be simplified again to force in the y direction is equal to force of gravity times cosine theta. Use Newton's second law for each the x and the y direction. The sum of all forces in the x direction is equal to mass times acceleration in the x direction, and that should equal to 0 because there's no movement. And in the x direction we have the force of gravity in the x direction minus the force of static friction, which goes opposite way. And that should both equal 0 again. So now we can further define these as force of gravity in the x direction as force of gravity sine theta minus F static, and F static can be using the definition of static friction, the coefficient of static friction times the normal force. So we'll write that here. Again, that should equal 0. You can rearrange it to equal force of gravity times sine theta is equal to static coefficient equals normal force. Now we're going to do the same for the y direction. We can put these two equations together, place this in there, or we'll substitute normal force for what we defined it as. And we substituted normal force with force of gravity cosine theta. Move this over to this side, cancel out the force of gravity, so you're left with sine of theta over cosine theta equals the coefficient of static friction. Theta is equal to tangent theta. If we plug in our variables that we know now, our static coefficient is 0.5. Now we can solve for theta by taking the arctangent of both sides, and that should equal to approximately 26 degrees. Thank you, and hopefully that helped you.